Hello, my algebros. We are looking at just multiplying rational expressions. We're going to break this into two parts. So this will be part one of this part of rational expressions that we did. And we're just looking at multiplying and simplifying our rational expressions. So when we look at this, we could do this a couple of ways. I could multiply straight across, right? Like I would with regular fractions. And I would go 2 times 6 is 12, and x squared times x squared is x to the fourth, and 3 times 12 is 36, and x times x to the fourth is x to the fifth. And then I could reduce my fractions here, right? And I'd get 1/3 x, and I'd be done. I could also simplify as I go. That's another way to do it. I could reduce these fractions as I go and do it that way. It's really kind of up to you. We talked about this in class already. So as things get larger, it's easier to simplify first, right? We can see that 15 goes into 30, and that's just going to be 1/2, right? And 16/24 also reduces to 2/3. Now, we could cross cancel the 2 and the 2 if we'd like, or we could just leave it alone. It's kind of up to you, right? And then I find that it's easier to go ahead and multiply your your variables with their exponents because you just get to add them up, and then simplify when you get to the end. So 2 6 is going to reduce to 1/3, and then who wins between a to the fourth and a to the second will be a to the fourth by 2, and then b to the third and b to the sixth. Well, b to the sixth will win by 3, and you're done, right? Go ahead and try this one. This is the you try we did in class, and pause it and check your solutions, and hopefully you could get to 2b squared. All right. Now we're going to look at multiplying when there's some binomials involved. Remember, binomials means that it's a family, so we have to factor first. We take out a greatest common factor when it's a binomial, and now we see we can reduce by a whole family first, and then multiply straight across. Now we really want to get in the habit of reducing this way, because when we have larger polynomials, like a binomial times a trinomial like this, we don't want to multiply straight across. That would have to mean box, FOIL, or stacking, and we'd end up with a 5-term, maybe a 6-term that we're trying to reduce, and we just can't think of those factors in our head that quickly. So we want to factor first. Always factor first. We take out a GCF here, and we get x plus 1. And then we have an x box here, which happens to be a perfect trinomial of x minus 3 times x minus 3. Then two terms that multiply to be 3 and add to be -4 are going to be -1 and -3. And then we take out a GCF of that binomial, getting x and x times x minus 1. So these are kind of fun because now we just get to, collect our socks like we talked about in class, our sock bin. So we look at the pairs that match, and we can take those out and reduce it until we get the leftover socks that don't have a match, basically, right? That's what we talked about before. Let's go ahead and do this you try, and we'll see how you do. All right, hopefully you factored out a GCF, and then you saw that there was a difference of 2 squares over here, so you can take out that x plus 4 and x minus 4, and then you're just reducing the x and the x, and then you have 2/4, which is just simply 1/2. Yep, that whole mess just refers to 1/2. And we did this homework, right? And now I'm going to pause here because I'm going to finish this in a minute.